Question 1a. Well, when we're multiplying, we add the powers. So 3 add 4 is 7, so m to the power of 7. Now in part B, we've got to cube each of the components of the bracket. So first of all, 5 cubed. That means 5 times 5 times 5, which is 125. Secondly, we've got to cube the n, so that's just n cubed. And then thirdly, we've got p cubed needing to be cubed. Now when we've got a power inside the bracket and a power outside the bracket, we multiply these together. 3 3s are 9, so that's p to the power of 9. So 125 n cubed p to the power of 9. Now in part C, we just work our way along, dividing the normal numbers, then dividing the q's, then dividing the r's. So 32 divided by 4 is 8. Now q to the power of 9 divided by q to the power of 3. When we're dividing, we subtract the powers. 9 take away 3 is 6, so q to the power of 6. Then finally the r's, we've got r to the power of 4 divided by r. Now r is r to the power of 1, so we've got r to the power of 4 divided by r to the power of 1. When we're dividing, we subtract the powers. 4 take away 1 is 3, so that's r cubed on the end. So 8 q to the power of 6 r cubed. Question 2a. So to find the lowest common multiple, just start doing your 40 times table and your 56 times table. Stop when you get the same number in both lists. So there's my 40 times table started at the top. Then my 56 times table I just did using my calculator, and you can see the first number we have in common is the 280. So that's the lowest common multiple. Now in part B, when we've been given the numbers already broken down to prime factor form, to find the highest common factor of A and B, we've just got to take out the biggest number of each of the numbers we can that is common to both lists. So when we're looking at the 2's, we've got a 2 cubed and a 2 squared. So the biggest one, which is common to both lists, is 2 squared. So that's the 2 squared. Then we move on to the 3's, well, we've got a 3 in both. And then moving on to the 5's, well, the biggest one we've got in common is just a single 5. So we take out the single 5. So 2 squared, which is 4, times 3 times 5 is 60. Question 3, we've got to find the equation for this line. So think back to the starting point of y equaling mx plus c as the how a straight line equation looks, with m being the gradient, the slope, and c being where the line crosses the y-axis. Now that's probably the one to start with first. That's an easy opening mark. So where does the line cross the y-axis? Well, it crosses at -6. So -6. Let's just get that into our answer. Now to work out m, the gradient, the slope, we need to take a triangle, take one as big as you can, and just try and make sure it's whole numbers. And then we want to find the ratio of the height of the triangle, the 6, that's the y step, and we divide that by the base of the triangle, which is 2. So 6 divided by 2 gives us 3. So 3 is a measure of the steepness. For every 1 square we go along, we go 3 up. So 3 is our gradient, 3 is m, so y equals 3x minus 6. Question 4. So let's start by finding out the total cost of the van. So the van is 8,500 plus VAT at 20%. So lots of ways of adding on the 20%. You could work out 10%, which is 850, and add a couple of those. Or you can say, well, for a 20% increase, we can use a multiplier of 1.2. That's what I've done. So 8,500 times 1.2 means the cost of the van, including the VAT, is 10,200. Now we're told that the rest of the cost is 12 lots of 531.25. So let's work out what that is, and that's 6375. So the deposit must be the difference. The deposit is the amount that we paid up front, leaving us just with that 6375 to pay. So take the cost of the van, take away the 12 equal payments, and that gives us the deposit of 3825. So the question asks us though to find the ratio of the deposit, the 3825, to the total of the 12 equal payments, which was the 6375. So we've got the ratio of the deposit to the 12 payments, and we've just got to give this in its simplest form. So a number of ways of doing that. We can just keep on breaking it down. So I've divided by 5, then by 5 again, then by 3, and then by 17. So to get the final ratio of 3 to 5. Or you might have just tried to see right at the beginning whether you could go straight to the end. If you do 3825 divided by 6375, you get 3 over 5. So you can see the ratio of 3 to 5 there. Question 5. So this is going to be a quadratic graph because we've got the x squared, and because this is positive, we're going to get a positive parabola, or a sort of smiley face shaped graph. So as we fill in these values, do look out for the symmetry of the y values. So I'm going to start off with some of the easier positive values. So I'm going to substitute in x being 1 to start with. So I'm just popping 1 into the function. So 1 squared, take away 1, take away 6, and I get a y value of minus 6. So when x is 1, y is minus 6. Now straight away I can see the symmetry. I've got the minus 6 to the minus 6. So just sort of think of the ripple effect as we move out. I mean, I know I haven't worked out these values here yet, but what I do know, when I work out this value here for 2, it's going to be the same as the value for minus 1. Similarly, when I work out the value for 3, it's going to be the same as the value for minus 2. So really I only need to do the work over here and then just rely on the symmetry over here. So anyway, let's work out the y value when x is 2. So substitute 2 into this. So 2 squared, take away 2, take away 6, gives us minus 4. And as I said, because we've got minus 4 here, just sort of from the ripple effect, the value must also be minus 4 for the minus 1. And then finally, when x is 3, 3 cubed minus 3 minus 6 gives me 0. And again, therefore that one must be 0. So I can then go for part B to plot these values. So I've plotted these values. Apologies that this is not as smooth a curve as I would have liked, but it's quite hard to do it on the screen. So just make that a nice gentle curve, no straight lines, and make sure it's curvy at the bottom. Don't make it flat at the bottom, it's not a vase. Now for part C, use your graph. So make sure you do use your graph to find estimates for this equation. Now you'll see that the left hand side is our curve, and we've just got to set this equal to y equaling minus 2. So just pop in the line y equaling minus 2 and take a reading for where your curve hits your line y equals minus 2, and my two readings come in at about minus 1.6 and 2.6. There will be a little bit of flexibility in the answers, so don't worry if your answers weren't quite the same as these, but just make sure you take an accurate reading from your graph. Question 6. So let's start by looking at the initial situation where we've got a force of 70 and an area of 20. So like the formula says, pressure equals force over area. So 70 over 20 gives us a pressure of 3.5. Now once we go and look at the changes, let's see what our new pressure is. So the force is increased by 10, so it goes up from 70 to 80. And the area is also increased by 10, so that goes from 20 up to 30. So using our calculator, 80 over 30, we get 2.6 recurring. So what is our decrease in pressure? Well, if we do 3.5 take away 2.6 recurring, we get a decrease in pressure of 0.83 recurring. So what is the percentage decrease? What is the pressure decrease in percentage terms? So remember, we do the decrease divided by the original amount. So make sure you divide the 0.83 recurring by the original pressure of 3.5 and then multiply this by 100 to give us a percentage, and we get 23.809 ... So the pressure is decreased by this amount. This is not less than 20%, so Helen is wrong. Helen is not correct. Question 7. So when we enlarge a shape by scale factor a third, it becomes a third of the size, and it will be a third as far away from the centre of enlargement. So it's going to be over here somewhere. So I would suggest you put in these sort of safety net lines, if you like. So just on all the corners, just do a line back to your centre of enlargement. So all your points should be on those lines. So just think of it as sort of backup, really. So let's start off with this point here. Now that's presently 3 along and 3 up. Now it's going to have to be a third of that. So rather than 3 along and 3 up, that's going to be 1 along and 1 up. And yes, that's on one of my blue lines. So there's my first point. Then if I move over here, well, that's presently 6 along and 6 up from the centre of enlargement. So a third of that's going to be 2 along and 2 up, and so on. So just work your way around all the points and in terms of how far along and how far up from the centre of enlargement, not the origin, from the centre of enlargement. Just divide each of those by 3 and you will get that shape there in red, and that is a third of the size, and it is a third as far away from there as this shape. Question 8. Now I think when you get one of these questions with a lot of information involved, involving males and females or boys and girls, and then you've then got to break the information down across 2 or 3 options, so it might be like languages or what have you. Here we've got Britain, Spain and Italy. Then I think a two-way table is a good way to just sort of gather your thoughts. So I've got Britain, Spain and Italy across the top, and male and female going down, and then we're going to have a total column and a total row at the bottom. So start off by filling in all the information you're given. 60 people in total, there's our 60, 38 males in total, 11 of the 32 people who said Britain were female, there's the 11 and the 32, 8 males said Italy, and 12 people said Spain. Now once I filled those in, you can then just fill in all the red numbers just by filling in the gaps. So for example, that 21 came from 32 take away 11 is 21. Then I can fill in the 9, then I can fill in the 3, then I can fill in the 16, then the 8 and then the 22, for example. So fill in all the gaps. Now to answer the question, one of the females is chosen at random, so we know they're female, so we're choosing out of the 22 females. Now we're being asked, what is the probability that that female said Spain? Now Spain females is 3, so it's 3 out of the 22 females. So 3 out of 22. Question 9. So we're told that by the end of the first year the investment is worth 12,336. So given that we invested 12,000, the actual interest we've made must be 12,336, take away the 12,000, which is £336. Now if we then take that interest and divide it by the original amount, we get this as a decimal of the interest rate. So as a percentage, timesing this by 100, we get a 2.8% interest rate. Now we're told in the second year that the interest rate halves, so that goes down from 2.8% to 1.4%. Now if we've got a 1.4% interest, then our multiplier is going to be 1.014. So taking the 12,336 we start with as we go into year 2, multiplying this by our multiplier, we end up with £12,508 and 70p once we round it. Question 10. So for part A, draw and label vector minus 2a. So it's twice the size of A, but going in the opposite direction. So rather than 1 to the right and 2 up, we're going to go 2 to the left and 4 down. So that's an example of minus 2a. Now, we want to work out what 1 lot of A plus 2 lots of B would be. Now, A is 1 along and 2 up. So that's the column vector 1, 2. And B is 1 along and 3 down. So that's the column vector 1 minus 3. So we want 1 lot of the A added to 2 lots of the B. So 1 lot of 1, 2 and added together with 2 lots of the 1 minus 3. So that's what I've done down here. So 2 lots of the B, 2 lots of the 1 minus 3, 2 times 1 is 2, 2 times minus 3 is minus 6. So it's 1 over 2 plus 2 over minus 6, so just add across, 1 and 2 is 3, 2 added together with minus 6 is 2 minus 6, which is minus 4. So 3 minus 4 is our final answer. Question 11. So f of minus 5 just means we substitute minus 5 into the f function. So 2 over minus 5 squared. Now just be careful, minus 5 squared is plus 25. If you're using your calculator, remember to protect the minus by popping the minus 5 in a bracket before you square it. So 2 over 25. You could give it as a decimal, but a fraction's fine. Now for part B, just be careful here. You first of all substitute 1 into the g function and see what output you get, and then put that output into the f function. So it's g first, f second. So first of all putting 1 into the g function, so 1 into here. So 1 cubed is 1 times 4 is 4. So we now take this output of 4 and put that into the f function. So that's going to be 2 over 4 squared, which is 2 over 16, which is an eighth. Question 12. So, if something is directly proportional to something, as one goes up, the other goes up at exactly the same rate. So that's going to be the straight line going upwards, so that's B. Now, well, y is directly proportional to x squared. It is going to be going up, but it's going to be going up as an accelerated rate because you're squaring the x value. So that's going to be graph D. Now, when y is proportional to the square root of x, while it's still going to be an upward curve, it will be decreasing. So that's going to be our graph A. And the only one which is actually going downwards is going to be one of our reciprocal graphs like 1 over x. So that is where y is inversely proportional to x. Question 13. Now there is an alternative approach to part A where you use the alternate segment theory, which is absolutely fine, but I'm going to go a bit more back to first principles and a little bit more back to the more common circle theories. So the first thing I've done is put in the line B to O, sort of creating this isosceles triangle because B to O and O to D are both radii of the circle. So looking at triangle BOD, we can see that this angle OBX must also be x because base angles of an isosceles triangle are equal. Now, if both these angles here, these two base angles, are both the same, then this angle BOD must be 180, take away 2 lots of x, because angles in a triangle add up to 180 degrees. Now, comparing this angle BOD with the angle BCD, we can utilize the circle theory that the angle at the circumference is half the angle at the center. So this angle here must be half of the 180 minus 2x, and halving this we get 90 minus x. So that's my reason there in blue. Now finally what I can say is that this angle y plus this angle 90 minus x, together they must add up to 180 degrees, because opposite angles in a cyclic quadrilateral add up to 180 degrees. So 90 minus x plus y equals 180 for the reason I just gave. So just rearranging this, so taking away 90 from both sides, I get minus x plus y equaling 90, or in other words, y minus x equals 90, as required to show. Now for part B, Dylan was asked to give some possible values for x and y, and he starts off by saying y could be 200. Well look, y is an angle in a triangle. Now angles in a triangle add up to 180, so there's no way y could be 200. Y's got to be less than 180 degrees. as it is an angle in a triangle. Question 40. Now we're being asked to use the graph to estimate the speed of the car at time 5 seconds, so here. Now I think these questions are very unsatisfactory because they're requiring you just to draw in a tangent at 5 and work out the gradient of the tangent, and it's so difficult to draw in a tangent accurately by eye. I just think it makes a bit of a farce, and you can see by the mark scheme any answers between 11 all the way up to 19 were allowed, which is just silly really. But anyway, we are where we are. So draw a tangent at 5, and if I were you, just be a bit smart. Make sure as you're popping your line in, you just keep the triangle nice, sensible, exact length. So I've popped this line in here as a tangent at 5. Now I now just need to work out the gradient of this tangent. So gradient is the y step over the x step, and my height here is 70, my y step, and my x step, the base of the triangle, is 5, going from 3 to 8. 70 divided by 5 equals 14. But as I said, as long as you've used your tangent and you've properly then divided your y step by your x step, you'll get the marks anywhere between 11 all the way up to 19. Question 15. So, as the chances of him winning on Saturday is 0.45, the chance of not winning must be 1 take away 0.45, which is 0.55. Now we're told that if he wins on Saturday, so if we're up here, chances of winning on Sunday is 0.67, so 0.67 up here, and therefore the chances of not winning on a Saturday must be 1 take away 0.67, which is 0.33. Now we're also told that if he does not win on a Saturday, the probability of winning on a Sunday is 0.35. So again, the probability of not winning on a Sunday must be 1 take away 0.35, which is 0.65. Remember, these two lines, the probabilities must always add up to a whole. So these two must add up to a whole, these two up to a whole, these two up to a whole. Right, part B, find the probability that the team will win exactly one of the two matches. So how do we win exactly one of the two? Well, we either win and then don't win. That's what I'm writing down as probability of W dash. That means win then not win. So that's one possibility where we will win exactly one match. Or alternatively, we could not win on a Saturday but then win on a Sunday. So the yellow path and the green paths are the ones we're interested in. So let's start off with the probability of winning then not winning. So that's 0.45 multiplied by 0.33. We've got to win on the Saturday and win on the Sunday. When it's an and, you multiply the probabilities, giving us 0.1485. Now alternatively, to win exactly one match, we could not win on a Saturday and then win on a Sunday. So that's 0.55 times 0.35, giving us 0.1925. Now we don't mind whether this is the scenario or this is the scenario in order to win exactly one of the two matches. So we don't mind whether we did it this way or this way. Now as it's an or, we therefore add these probabilities together, which I've done down here, giving us 0.341 as the final answer. Question 16. Now one of these where we have an x squared plus a y squared equaling something, it is the equation of a circle with centre 0, 0 and radius squared of 12.25. So 12.25 is the radius squared. So if we square root 12.25, we get the radius of the circle, which is 3.5. So just get out a compass, put the pin on 0, get a radius of 3.5 and draw a nice circle for part A answer. Now for part B, hence, so we've got to use the graph, find estimates for the solutions of the simultaneous equation of a circle and a straight line. 2x plus y equaling 1 is a straight line. So to draw a straight line we need a couple of points. So for example, when x is 0, y must be 1, Or another example would be when x is 2, y must be minus 3. Because 2 2s are 4, 4 take away 3 gives us our 1. So plot the points 0, 1 and 2 minus 3, and then carefully get out a ruler and draw a straight line through those points. You might want to do a third point for luck. And estimates for the solutions of the simultaneous equation are where the line cuts the curve. Now for mine, I've got answers of minus 1.2 and 3.3, and this coordinate here is 2 minus 2.9. So when x is 2, y equals minus 2.9. When x is minus 1.2, y equals 3.3. Again, there will be a little bit of leeway in the answers because it's quite hard to see exactly where they cross, and the question is asking for estimates, but just make sure your values exactly represent where your line crosses your circle. So for part A, we're being asked to complete the frequency table. Now the frequencies represent the areas of each of these bars. So we can see, for example, with the first one, we can just check that. We've got a base of going from 0 to 5, which is 5, a height of 0.8, 5 times 0.8 gives us a frequency of 4. So each of these answers here are just as working out the base times the height of each of the rectangles. So the second bar, a base length of 10, a height of 0.4, 10 times 0.4 is 4. The third column, we've got a base of 10, a height of 0.6, 10 times 0.6 is 6, and so on. So fourth column, base of 5, height of 1, 5 times 1 is 5, and finally this bar here, base of 20, height of 0.2, 20 times 0.2 is 4. Now for part B, we're being asked to find an estimate for the lower quartile of the times taken to finish the puzzle. So if we add up all our frequencies, we get 23. So our lower quartile, quarter of the way up, the best way to find that is to do 23, add 1, and then divide this by 4. So we're looking for where our sixth person is. So what time was taken by our sixth person? So let's just work our way left to right and trying to get a total area of 6. So the frequency of the first bar is 4. That's the 4 people there. So we haven't got to our sixth person yet. Now, given that 4 have gone and we want our sixth person, we want 2 more people. Now this bar represents 4 people. So we want to go 2 more people, so we want to go halfway along this bar. So halfway between 5 and 15, which is taking us to 10. So in other words, what I'm saying is, to the left-hand side of 10, we have an area of 6, because we got the 4 in the opening bar, and half of this second bar, giving us a combined total area, total frequency of 6. So time taken is 10 minutes. Question 18. Now I think almost the hardest bit of this question is to understand exactly what angle they're getting at. So they're asking to find the size of the angle between AH and the plane ABCD. And I find that conceptually quite hard because AH is a line, but ABCD is an area. But anyway, what you have to do, go from A to H, and then literally just go straight down from H. So that's taking us down to C. So the triangle we're going to be working with is the triangle AHC. So I would suggest you just get a little two-dimensional representation of this straight away. So we're trying to find the angle here, the angle between H and A and C. That is our ultimate goal. And what do we know so far? We know the length CH is 8.1. Now, in order to be able to find out this angle, I'm going to need to be either work out AH or I need to work out AC. And from the other information I've been given, I can see that I can work out AC by sort of concentrating excuse me, on this triangle from the base, really. So if I think about the triangle A to B to C, the angle ABC is a right angle. It's that corner over there. I've been told that angle BCA equals 48 degrees, and I'm also told that the length AB is 7.3. So I can now, using SOHCAHTOA, work out the length AC. So using sin 48 equals my opposite side of 7.3 divided by my hypotenuse of AC. Then multiplying by AC and dividing by sin 48, I can see that AC equals 7.3 divided by sin 48, which is 9.823 ... So I've now worked out what AC is. So I can now go back to my original triangle and work out the angle X, the angle I need. So this time using tan, I can say tan X equals my opposite side of 8.1 divided by my adjacent side of 9.823 ... So X equals inverse tan 8.1 divided by 9.823. So X equals 39.508, which rounds to 39.5 to 1 decimal place. Question 19. So I need to work out the surface area of this shape, but what they give me as a starting point is the volume of this shape. Now, if I'm going to work out the surface area, I'm going to need to know the radius of this shape, and I can do that from the volume that they give me. So I'm going to focus first of all on working out the radius of this shape from the volume information. So the volume of a whole sphere is 4/3 pi r cubed. So obviously the volume of a quarter of a solid sphere must be a quarter of this, which is 1/3 pi r cubed. And I'm told that this volume equals 576 pi. So immediately I can cancel my pi's. Then if I multiply both sides by 3, I get r cubed equaling 1728. Cube root this, I get r equaling 12. So the radius of this shape is 12. So I now need to get the surface area of this whole shape. Now this combines 3 surfaces. I've got the 2 flat semicircles and I've got the curved surface area. So I'm going to start off with the surface area of the curved surface area. Now if it was a whole sphere, the surface area of the whole sphere would be 4 pi r squared, but this is only going to be a quarter of that. So a quarter of 4 pi r squared is pi r squared. Just worked out that the radius is 12, so pi times 12 squared, which is 144 pi. So that's the surface area of the curved surface of this shape. Now I've now got these 2 semicircles that I need to cover in wrapping paper, if you like. Now each of the 2 semicircles together, of course, is going to form a whole circle. The equation of the area of a circle is pi r squared. So again, pi r squared cropping up. So another pi times 12 squared. So another 144 pi. So total wrapping paper needed, 2 lots of 144 pi, which is 288 pi. We're being asked to give our answer correct to 3 significant figures. So change this into a decimal. So 904.778. So to 3 significant figures, that's 905. Question 20. So where did Martin go wrong? Well, Martin went wrong on the second step here when he did the multiplying out. So step 1 was okay. He chose to multiply by the correct bracket. He remembered to change the sign of the denominator. But where he went wrong was when he was multiplying out these pair of brackets, and that final claw, that plus root 3 times that minus root 3 should have given him minus 3 here and not plus 3. So root 3 times minus root 3 is minus 3 and not plus 3, as Martin said. Now where did Sian go wrong? She went wrong when she was trying to simplify this root 12. Root 12 is root 4 root 3, which is 2 root 3. So root 12 is 2 root 3 and not 3 root 2. Question 21. Now, we've got to consider bounds to get a suitable degree of accuracy. So in order to do that, we've got to work out the upper bound for density and the lower bound for density. Now, to work out the upper bound for density, we want to maximize the numerator but minimize the denominator, because big divided by small is going to give us big. So we're going to kick off in a bit and work out the upper bound of mass and divide this by the lower bound of volume. That will give us the upper bound for density. And then secondly, we're going to work out the lower bound for density, and this is the other way around. We get the smallest value for density when the numerator is as small as possible, but the denominator is as big as possible. So we're going to do the lower bound for mass divided by the upper bound for velocity. So that's our goal. Now obviously we've got to work out these upper bounds and lower bounds first, so I've done that over here. So the mass is 1970, correct to the nearest 5 grams. Now, because it's correct to the nearest 5 grams, we're going to go up or down half this amount for our upper bound and lower bound. So we're going to go up or down 2.5 grams. So that's why my upper bound for mass is 1972.5 and my lower bound for mass is 1967.5. Now, moving on to volume. The upper bound of volume is going to be when I maximize all of these lengths. Now these are all correct to the nearest minimum, nearest millimeter rather. So 13.2, the maximum that could be is 13.25. 16.0, the maximum that could be is 16.05. And the height of 21.7, the maximum that could be is 21.75. So multiplying those three together gives me this, which is the upper bound for velocity. Now the lower bound for velocity is when each of these are as small as possible. So 13.15, 15.95 and 21.65. Multiply those three together and I get this. So back to my calculations over here. So for my upper bound for density, I wanted the upper bound for mass, which is my 1972.5, and divide that by the lower bound for volume, which is the 4540 number, and that gave me 0.43438, blah blah blah. Now my lower bound for density is my lower bound for mass, 1967.5, divided by my upper bound for volume, the 4625 figure, giving me this. Now, once I've got my upper bound and lower bound, to get my suitable degree of accuracy, I try and see as I go along from 1 decimal place, 2 decimal places, 3 decimal places, and so on, where would I round both of these and get the same answer? So to 1 decimal place, of course, I would get 0.4 on both occasions. So they definitely agree to 1 decimal place. What about 2 decimal places? Well, this would be 0.43, and so would this. This would also be 0.43. So they agree to 2 decimal places. Do they agree to 3 decimal places? Well, this one would be 0.434, but this one would be 0.425. So they do not agree to 3 decimal places. So we can't go that far. We've got to stick at 2 decimal places. So we say the density of the wood is 0.43 as they agree to 2 decimal places.